All right, hello everybody. Today we're going to be working with what we call the quadratic formula, as you can see on this page. And so here we go. Get your pencils ready, highlighters, everything else that we normally use. So solving the quadratic equation using the quadratic formula. Now, last week we talked about that when we solve a quadratic, we're looking for the x-intercept. So that's why if we look at all of our pictures down here, we would say, okay, this one has, as it says down there, two x-intercepts. This one would only have one x-intercept because it only hits the x-axis once. And of course, that last one has no x-intercepts at all. Notice how it never touches the x-axis. When solving a quadratic, that's what we're looking for. We're looking for those x-intercepts. That's why we call them zeros, we call them roots, we call them x-intercepts. They go by different names. So in order for us to find them today, instead of factoring, instead of using square roots, at least just the square root rule that we learned the other day, we're going to be using the quadratic formula. Now, the quadratic formula says we're going to let A, B, and C be real numbers. But of course, we've mentioned that your A value can never be a zero, because if your A value is zero, then it ceases to be a quadratic equation. So it says the solutions of a quadratic equation. Now I'm going to highlight this, but here comes an important note when it comes to the quadratic formula. In order for us to apply the quadratic formula, first of all, it needs to be in standard form, which is descending order. And what that means is we start off with an x squared, then the single x, then the no x, of course. So we want it to be in standard form. And here's the other thing that we want. It must equal zero. So we have to have a zero on the left or on the right, but it must equal zero. In order for the quadratic formula to work, notice it has to equal a value of zero. So it has to be in order, equal to zero. And if it does, if we have all of this information in there ready to go, then we can finally apply what we call the quadratic formula. Now, this dates back to our Algebra 1 days, where our A, B, and C are going to be used. And again, our A, B, and C that we mentioned earlier are just the numbers, no other letters. But you have to remember that if you're going to apply the quadratic formula, first of all, you need to say x equals, because we are solving for x values, right? X-intercepts. And then we're going to plug in ones for the letter B, plus or minus the square root, another B value squared, minus 4, and then it's A times C all over. Look at how we stretch out that fraction all the way from the beginning to end, all over 2A. Notice how we have 5 empty parentheses, and technically we should be filling in for 5 different spots in this formula. And the formula here tells you exactly what numbers to use. It's also in your word wall to guide you. But with the quadratic formula, there's a very important part. It's called the discriminant. And notice how the order needs to be the same. It needs to be in standard form. It has to equal zero. But look at what the discriminant represents. It says the discriminant is the b squared minus the 4ac. It's the inside of our square root. So the discriminant is a part of the quadratic formula, but there's a big difference. We use the quadratic formula to solve for our x-intercepts. That's why it says x equals. Notice how the discriminant is only used for analyzing. There's no x equals b squared minus 4ac, because this is not going to give me a solution. It will do something for us, though. It will tell me how many solutions I'll have and what type of solution I'll have. But that's the one thing to remember. The discriminant, it is not used to solve a quadratic. We use it for other things, again, and we use it for analyzing. But the answer that I get from it is not the solution to the problem yet. There would still be more that we would have to do. Now, a few other things we want to mention that we see written down here in our table. Now, this same little table is also in our word wall, so you may want to add some of the information we're going to use here into your word wall. And the first thing it says, if b squared minus 4ac is greater than 0. Well, we've seen that type of terminology before. Here's what they're trying to tell me. They're saying if b squared minus 4ac ends up being a positive number, so if you do the discriminant and you get a positive number, it says you're going to have 2 real solutions. Now, physically, that means it's going to have two x-intercepts just the way we pointed out earlier. So when your discriminant is positive, we know we're going to have two real answers. And if I were graphing, it would mean that I would have to find two x-intercepts for that problem. Now, look at the next one. It says, if my discriminant, the b squared minus 4ac, is equal to 0. So not a positive number, right? Not a negative. If it actually becomes a 0 value, then what they're saying is I'm only going to have one real solution, aka, look at our graph, it means it's only going to have one x-intercept. So again, everything here, my answer to my discriminant, this is what's going to help me analyze the problem. And of course, to end it here, it says, well, what if your discriminant is less than 0? Well, our values that are less than 0 means that we're dealing with the negative. So if my discriminant is negative, it says this is where we're going to have two imaginary solutions. So they're not real anymore. So notice we do have to bring in that distinction. If I have two imaginary, the reason it's imaginary, remember, the discriminant is coming inside of a square root. And if we have a negative inside a square root, that's what we've learned about complex numbers. That's when the I would come out in my solution. So what they're trying to tell you here, and again, this is why it helps us analyze, we're basically telling ourselves that I will be in our answer. That's what we're looking at here. If we have a negative for my discriminant, then I'm going to have two imaginary solutions. So I just have to remember that the letter I will be in our answer. Again, all of this is just part of the analyzing and where it helps me. And if you have two imaginary solutions, well, then of course it has no x-intercept. It's never going to cross the x-axis. All right, so let's put this into practice. Okay, we're going to be looking for the discriminant first. That's all we're going to practice to begin with. And we're going to tell ourselves, this is how many answers I'm expected to look for. Only discriminant first. All right, so here come the examples. It says, use the discriminant to determine the number of solutions. So they don't want me to solve. Notice they never said solve it. They said, what's the number of solutions I'll have? Okay, here we go. So when I'm looking here, my A value is 1. You can never say 0. You can't say there's nothing there. B is equal to -7. Notice I'm not bringing letters into the mix here, no x's. And my C value is -18. So my discriminant says B squared minus 4AC, which means I have 3 unknowns that need to get plugged in. So if I follow the formula, which is what you're supposed to do, B is equal to -7, A is equal to 1, and C is equal to -18. All right, so now we're going to work all of this out. And again, this is where your Desmos calculator can help us. Obviously, I can't put the Desmos calculator on video here for this one, so I'm just going to use this one. So we type it in. So -7 squared, just realized, -7 squared power of 2 minus 4 parentheses 1 parentheses, yes, a bunch of parentheses, -18. And just like that, I get an answer of 121. So yes, you are expected to use a calculator for this so that you can finish it a little bit faster. So there's my discriminant. Again, it doesn't say x equals. This is not a solution. Here's what I want to get from here. The fact that this is a positive 121, the question is what's the number of solutions you're going to get? Because it's positive, I know I'm going to have 2 real solutions. That's how we use the discriminant. We don't know what those answers are yet. 121 is not one of my solutions. The fact that it was positive, it means it has 2 real solutions, which also would mean it has 2 x-intercepts. But I know that for your assignment, they're just going to want this, the 2 real solutions instead. And that's it. That's all we get from discriminant. We know we're going to have 2 real solutions that I'll eventually solve for. Let's try it again. My A value is 3. My B value is -3. Don't forget those negatives. And my C value is -5. All right, so here comes that discriminant. B squared minus 4AC. It's always the same formula. Something squared, 4 times something something. We have 3 spots available here. Make sure you put the information where it belongs. B is -3. Yes, you throw the negative in there. The A is 3, and the C is -5. There, we have thrown in our values where they belong. We didn't leave out a negative. And so now, here we go again. So, -3 squared, I would type it in exactly like this on Desmos, minus 4 parentheses 3 parentheses -5. And so we get an answer of 69. The number doesn't matter though. Remember what we just said earlier. What matters according to the discriminant is the fact that this is a positive number. And if my answer is positive, then it means I'm going to have 2 real solutions, also known as roots, as zeros, and most importantly, also known as x-intercepts. So I would have 2 x-intercepts. But again, on your homework, all we need is the 2 real solutions written out. All right, so hopefully you're getting the idea here. It's very straightforward. So let's look at number 3 here. Here we go again. A is equal to 2, B is equal to -4, and C is equal to 5. All right, here we go. Something squared minus 4 AC, but every time I say a letter, notice how we're just going to jump right into it like you should in your notebook today on your homework. All right, B value, -4. A value, 2, C value, 5. And once again, once you fill that out, let's use the tech that we have available for ourselves. All right, so here we go again. -4 quantity squared, minus 4 parentheses 2 parentheses 5. And look at that. We got an answer of -24. And again, the 24 is not the solution to the entire problem. What I'm looking at is this. This is who's calling the shots. And because it's a negative number, look at what we said. If you have a negative value, you're going to have 2 imaginary solutions because it never touches the x-axis. These are imaginary, no x-intercepts. But my answer that I would put in my homework is 2 imaginary solutions. You know what? I'm also going to write root. Roots is just another way of saying solution, but it's a little bit shorter to write. Just remember, this means no x-intercepts. Okay. All right. One more to go here. Let's give this one a try. A is equal to 1, B is equal to -4, and C is equal to 1. All right, here we go. B squared minus 4AC. Yeah, I said the letters, but I didn't write them down because I'm going to be plugging in for them anyways. My B is -4. My A is a 1. My C is a 1. So we worked that out on our calculator there. All right, here we go. So once again, -4 quantity squared, minus 4, parentheses 1, parentheses 1. Not much there, so we ended up with a positive 12. And because it's positive, we've seen this one plenty of times already. We're going to have 2 real solutions. Very straightforward. Okay, now we're not done with the notes, but we're going to pause for a moment with this video so that you can try out some of these problems on your own. So get your worksheet ready and let's get started with that.